Alright, so lesson 3-8, solving systems of equations using inverse matrices. So by the time we're done with this lesson, we should be able to find the inverse of a 2x2 matrix, write and solve equations for a system of equations. So starting with identity matrix, this is a square matrix that when multiplied by another matrix equals the same matrix. So we use the notation I sub n to identify the identity matrix. And when we look at it, we're going to see ones along the diagonal and zeros everywhere else. So each of these is an example of an identity matrix for a 2x2, a 3x3, 4x4, and we could keep going if we wanted to. So again, the identity matrix is the same idea as 1 in our real number system. So if I take 1 times 2, that equals 2. So if I take this 2x2 identity matrix times another 2x2 matrix, we're going to get that same matrix back. So when we multiply by the 1, it doesn't really do anything. Okay. So the identity is also helpful for us to figure out an inverse. So remember, an inverse is the same idea as an opposite. So like addition and subtraction are inverse operations because they undo each other. Okay? Same with multiplication and division. So if I take 2 times 1/2, that gives us 1. So we're undoing that operation. So we use the identity matrix to help us figure out a multiplicative inverse for a matrix because it's a little bit harder to see that. Now some, but not all matrices have a multiplicative inverse. So, and the notation for an inverse is this a to the negative 1. So we would read that as a inverse. So again, if two matrices are inverses, if we multiply them together, we should get the identity matrix. So we're just going to start by practicing multiplying matrices together to see if they're inverses of each other. So if we take a look at problem 1, for multiplying matrices, again, we want to start with the dimensions. So here we have a 2x2 and another 2x2. So we're looking for the inside numbers to match, and if they do, then we use the outside numbers for our new dimensions. So we are going to have a 2x2 matrix when we are done. So again, this is the first row, first column. So I'm going to take the first row times my first column. So 2 times 2 is 4, and then 3 times negative 1 is negative 3. Here we have first row, second column. So again, first row, and then now we are in the second column. So 2 times negative 3 is negative 6, and 3 times 2 is positive 6. Okay, second row, first column. So now we're using our second row times our first column again. So 1 times 2 is 2, and then 2 times negative 1 is negative 2. And second row, second column. So again, second row, second column. So 1 times negative 3 is negative 3. 2 times 2 is 4. And now we're just simplifying that. So 4 plus negative 3 is 1. Negative 6 plus 6 is 0. 2 plus negative 2 is 0, and negative 3 plus 4 is 1. So this is the identity matrix, so that means yes, these two matrices are inverses of each other since we multiplied them and got the identity. All right, let's do another example. So again, we're going to start by writing down the dimensions. So we have a 2x2 and a 2x2. So that means that we are going to have a 2x2 matrix when we multiply them. So again, starting with the first row and the first column. So negative 4 times 1/4 is negative 1. And then 2 times 1/2 is 1. Okay, and then now we're in the first row, second column. So now we're going to use the second column here. So negative 4 times negative 1/2 is positive 2. 2 times negative 1 is negative 2. So plus negative 2. Okay, second row, so now we're using these numbers, and then our first column again. So negative 2 times 1/4 is negative 1/2. And then 1 times 1/2 is 1/2. And the second row, second column. So negative 2 times negative 1/2 is positive 1. And then 1 times negative 1 is negative 1. So when we simplify, we would have negative 1 plus 1 is 0. And then 2 plus negative 2 is 0. Negative 1/2 plus 1/2 is 0. And 1 plus negative 1 is 0. So we did not get the identity matrix. So no, those two matrices are not inverses of each other.